So for section 8.1, I'm going to work through some of the problems on page 660 with sequences. So the first one I'm going to look at is number 8. Number 8 asks us to find the first 4 terms of the sequence. So here's the formula given. A subscript n equals 2n plus 1. On these problems, you'll be replacing n with 1, 2, 3, and 4, since we're looking for the first 4 terms. So a subscript 1, or the first term, will be 2 times 1, because n is 1, plus 1, which would equal 3. A subscript 2, or the second term, would be 2 times 2 plus 1, which equals 5. The third term would be 2 times 3 plus 1, which will equal 7. And the fourth term will be a to the subscript fourth equals 2 times 4 plus 1, which equals 9. So these would be the first 4 terms in the sequence where n is replaced with 1, 2, 3, and 4. Okay, let's try another one similar to that. So look at number 12. And on number 12, again, you're given a formula. So the formula is a subscript n equals n to the third. And you're replacing n with 1, 2, 3, and 4 because you want the first 4 terms in the sequence. So a subscript 1 is going to be n to the third, or 1 to the third, which equals 1. A subscript 2 equals 2 to the third, which will equal 8. A subscript 3, or the third term, is going to be 3 to the third, which is 27. And the fourth term will be 4 to the third, which equals 64. So the first 4 terms will be 1, 8, 27, and 64. Okay, so now let's go ahead and look at one where we're going to write the general term. Okay, so on these, so this is where we're going to write an explicit formula. So we're going to be writing an explicit formula. Let's look at number 28. So we're going to write an explicit formula. That's the kind of formula we're writing when they ask you to look at the terms and see what the pattern is basically. On these, we are going to assume that n begins with 1. So we assume n begins with 1. So first, let's look at, 28. So on here, the terms that they give you are 7, 9, 11, and 13. So what I'm going to do is I'm going to say, okay, this is my n. So for the first, for when n equals 1, the term or the answer is 7. When n equals 2, 3, and 4. So as you can see here, the terms are going up by 2. So that basically is going to be your slope, or what you're going to multiply times n, what you're going to multiply by n to get to in your formula. So the formula is going to be a subscript n equals 2 times n. So then here, look to see what's going on from how you can go from n to the term. So here, if I take this times 2, which is what we found by looking at what that was increasing by. So 1 times 2 is 2, but how can I go from 2 to 7? I would have to add 5. On the next one, where n is 2, 2 times 2 is 4. How would I get to the answer here, or that term? I would have to add 5. So the explicit formula is going to be 2n plus 5. Okay, let's look at one more of those. So let's look at number 32. So on number 32, we are given the terms of -3, 6, -9, and 12. So again, we assume that n starts with 1. So there's our first term, second term, third term, and fourth term. So first off, kind of ignoring the negative signs here for a moment, look to see what's the values are increasing by. So from 3 to 6, it goes up by 3, up by 3, up by 3, if we ignore the negative signs for just a moment. So this is what's going to be multiplied by n. So for your explicit formula, so it'll be a subscript n equals 3 times n. Then when they have the signs here rotating between positive and negatives, what you will do is you will have then -1 raised to the power of n. So let's test it out. So if n equals 1, so if we're finding when n equals 1, we would take 3 times 1, because that's what n is, and then we would multiply by that times negative 1 to the power of 1. So 3 times 1 is 3, and negative 1 to the first is negative 3, so negative 1 to the first is negative 1, so 3 times negative 1 equals negative 3. So that would work then. That is the explicit formula. Okay, now let's go ahead and look at some other sequences, which are going to be recursive sequences. So if you have a recursive sequence, then you are, the first term must be given, and the following terms depend on that first term. The following terms depend on that first term. Okay, so for example, let's look at number 42. So on number 42, they tell us that the first term, or a subscript 1, equals 5, and they give us this recursive formula. A subscript n plus 1 equals a to the n minus 1. So this means that the following term, you will take the previous term and subtract 1. So our first term equals 5. So the second term, or a subscript 1 plus 1, to be the second term, would be the previous term, which is 5 minus 1, and that would equal 4. A subscript 2 plus 1, or basically the third term, is going to be the term right before it, or a subscript 2, which is 4 minus 1, which would equal 3. The next term, or a subscript 3 plus 1, or basically a subscript 4, would equal the previous term, which is a subscript 3, which is 3 minus 1, which would equal 2. And then finally, I would just like to go over with you how to simplify a factorial expression. So remember, when you have a factorial, so for example, if you have 3 to the third is equivalent to 3 times 2 times 1. So it's equivalent to that number, and everything, every number below that multiplied. So for example, 3 factorial is equivalent to 3 times 2 times 1, which equals 6. So let's look at number 58. The directions say to simplify. So we have 8 factorial divided by 10 factorial. So what you can do here, so 8 factorial, I'm just going to leave it as 8 factorial, is equivalent to 8 times 7 times 6 all the way down to times 1. Over, we have 10 times 9 times basically 8 factorial, which would be equivalent to the 10 factorial. So the 8 factorials will cancel out, and we're left with 1 over 10 times 9, which is 90. And that's all for today.